Reaction of carbonyl compounds with Grignard reagents. The addition of Grignard reagents to carbonyl compounds is an important reaction because it leads to the formation of carbon-carbon single bond. Grignard reagents can be prepared by reacting alkyl halide with magnesium shavings in diethyl ether under anhydrous conditions. So that is the most important thing. If you have even a speck of water, this reaction could be easily destroyed. The Grignard reagents can also be called as organomagnesium compounds, and it falls under the category of organometallic compounds. The R group in the organometallic compounds is going to behave as if they were carbanions, and they can act as a nucleophile. The Grignard reagents can react with aldehydes, ketones, and carboxylic acid derivatives such as acyl halides and esters. Now let's take a look into the mechanism of how a Grignard reagent is going to react with aldehydes and ketones. First, to begin with, the R group from the Grignard reagent is going to act as a nucleophile, making a nucleophilic attack on this electrophilic carbon, thrusting the electrons onto oxygen. Now this is going to create as a tetrahedral intermediate. But this tetrahedral intermediate that will be formed is relatively stable than the one that is formed in the case of carboxylic acid derivative, because we do not have any leaving group here. All of these groups right here are strongly basic and doesn't want to leave from the tetrahedral intermediate. But this O minus is going to get coordinated with the MgBr since this is positively charged. Now when you add a dilute acid, this complex will be broken up. So this O minus will get coordinated with the hydrogen from the acid. This will result in the alcohol. Now, depending on the substitution across these two carbons, you can get different types of alcohols. For example, when you react with formaldehyde, it's going to result in primary alcohol. Let's see how. Let's do the mechanism here again. So the R group, this R group is going to act as a nucleophile on this electrophilic carbon and thrust these electrons onto oxygen. So here it will form this tetrahedral intermediate. And in the next step, you're going to add dilute acid to it. And that's going to break up this complex to put an H there to give us the alcohol. And obviously you can see that this is nothing but propanol, which is a primary alcohol. This is going to be a primary alcohol. So formaldehyde, when it reacts with Grignard reagent, it is going to give us primary alcohol. In the same way, when you take a substituted aldehyde, so anything that is higher than formaldehyde, it's going to give us a secondary alcohol. So this is the tetrahedral intermediate that is created, and this is the methyl group that is added from the Grignard reagent. And when this molecule breaks down in the presence of an acid, it's going to give us a secondary alcohol. So this is the methyl group that is added, and obviously you can see that this is a secondary carbon where your OH is attached. And when you react the ketones with the Grignard reagent, it is going to give us a tertiary alcohol, because you can see that this part here will be converted to an OH, and you will add an ethyl group here since you are starting with ethyl magnesium bromide, right? So that would be the product that will be obtained here. So this ethyl group is coming from ethyl magnesium bromide. Right? So this is definitely a tertiary alcohol. So on the whole, formaldehyde reacts with Grignard reagent to give us primary alcohol. Any aldehyde that is higher than formaldehyde, when it reacts with Grignard reagent, it is going to give us secondary alcohol. And ketones, when they react with the Grignard reagent, it is going to give us tertiary alcohol. In all of these, a new carbon-carbon single bond has been formed. Carbon dioxide can also react with Grignard reagent, in which case it is going to give us carboxylic acid. Let's take a look into the mechanism here again. So this is the alkyl group which gets added to this carbon. You can imagine this is definitely a electron deficient because of the two electronegative oxygen atoms. So when it gets added, one of these pi bonds is going to break and those electrons are going to get shifted onto oxygen. And the next step, you're going to add acid to break up this bond so as to form the OH. Right? And as you can see from here, this is definitely a carboxylic acid. So when carbon dioxide reacts with Grignard reagent, it is going to give us carboxylic acids. Here are some more examples for the addition of Grignard reagents to carbonyl compounds, more specifically aldehydes and ketones. Now, when the reaction leads to the formation of a new asymmetric center, like in this case, where this carbon is an asymmetric center, the product is going to be a racemic mixture. In addition to aldehydes and ketones, Grignard reagents add to esters and acid halides to give tertiary alcohols, but they needed to undergo two successive reactions with Grignard reagents. The first reaction is a nucleophilic addition elimination reaction, which we normally see in the case of carboxylic acid derivatives. And the second reaction is a nucleophilic addition reaction. Let's see how we are going to get the tertiary alcohol. First, to begin with, the alkyl group from the Grignard reagent is going to make a nucleophilic attack on this electrophilic carbon, thrusting these electrons onto oxygen. Now, this is going to result in an unstable tetrahedral intermediate. Why should this be an unstable tetrahedral intermediate? Because we do have a leaving group. So, the tetrahedral intermediate, when it collapses, this leaving group is going to leave. Remember, this is the first methyl group that we have added from the Grignard reagent. This will give us a ketone. And in the second step, one more equivalent of Grignard reagent is going to react with this ketone to give us a tertiary alcohol. So this is our second Grignard reagent, and this is the alkyl group that's going to now get added. So this is going to have a positive charge. The alkyl group is going to have the negative charge that goes and comes and attacks this carbon, thrusts these electrons onto oxygen. Now this tetrahedral intermediate that is formed is stable because you do not have any leaving groups, and all of these groups are strongly basic. And so in the presence of a dilute acid, this complex is going to break here, and the O- is going to go grab this hydrogen from acid to give us the tertiary alcohol. And obviously you can see that this is a tertiary alcohol because the OH is connected to a carbon, which in turn is connected to three carbons. Here the reaction with first equivalent of Grignard reagent is a nucleophilic addition elimination, and the second reaction is a nucleophilic addition reaction. Likewise, acyl chlorides also undergo two successive reactions with Grignard reagents to give us tertiary alcohol. Here the leaving group would be Cl-. So again, to begin with, here we have ethyl magnesium bromide, where we have this R part or ethyl part, which will be acting as a nucleophile attacking this electrophilic carbon. This will form as the tetrahedral intermediate. This is the tetrahedral intermediate that's formed, and here is the alkyl group from the ethyl magnesium bromide. Now here, since we have a leaving group, as these electrons come in, this is going to leave. And it's going to give us a ketone. Now this ketone will undergo the reaction with the second Grignard reagent to give us a tertiary alcohol. Now in this case again, we do have a stable tetrahedral intermediate. So here is the originally added alkyl from the Grignard reagent, and this one from the second one. Okay. Now when you add dilute acid, this O- is going to get protonated and MgBr breaks away from the molecule. And this has obviously resulted in a tertiary alcohol. Here is the summary of all the reactions that we have covered in Grignard reagents with carbonyl compounds. With formaldehyde, it's going to give us primary alcohol, and with the aldehyde that's greater than formaldehyde, it's going to give us secondary alcohol. And with carbon dioxide, it will give us carboxylic acid. And in the case of esters and acid chloride, it will first get converted into ketone and then finally to tertiary alcohol.